In this video, we're going to do the free response that's labeled 2007 number 5. And it is talking about how researchers want to determine whether drivers are significantly more distracted while driving when using a cell phone rather than talking to a passenger. So in a study involving 48 people, 24 were assigned to drive in a driving simulator while using a cell phone, and the remaining 24 were driving in the simulator while talking to a passenger. And part of the driving simulation for both groups involved asking drivers to exit the freeway at a particular exit. In the study, 7 out of 24 phone users missed the exit, while 2 out of 24 talking to the passenger missed the exit. So before we even go, let's just make sure we understand what's taught. When you read this problem, you should think, okay, so we're trying to do a significance test, and so you first ask, is it proportion or mean that we're going to use? So hopefully you can see that you can't calculate a mean. This is a proportion problem. And then is it one proportion or two proportions? We have two different proportions, so this is a two-prop z test that we're going to do. So let's go ahead and just label our stuff before we even get started. We can say P1 will be the cell phones users, so 7 out of 24 missed their exit, which is, do I have that? I'll leave it as a fraction for now. And P2 will be the ones that had a passenger, and that's 2 out of 24. So we can see that our, you know what I should be putting in here? These are P hats. These were our sample proportions. We can see that these are different, but we're trying to see, are they significantly enough different to assume that the true proportions that miss their exits are different. So part A says, would this study be classified as an experiment or an observational study? So how do we know? As an experiment has treatment, right? So did they assign people to do something? Another thing you use for treatment is assignment. Or did they just take people that did this and compare people that did this, but they didn't assign one group to do one and one group to do the other? But if you look, it says 24 people were randomly assigned. So we know it's an experiment. So we just say this is an experiment because they randomly assigned the people to two groups, and one used cell phone and one talked to passenger. Okay, so when you address these, if it's an experiment, address the treatment. Don't just say because there was randomly assigned treatment. What was the treatment? So part B says, state the null and alternative hypothesis of interest to the researchers. So if you have already decided that it's a two-prop z interval, then you can go ahead and just jump in that the null, we know, is that there is no difference between the two proportions, that P1 equals P2. Or you could also write that, if you move it over to the other side, P1 minus P2 equals 0. No difference. Your null is always no difference. Now your HA is, what do we think? They want to test if they're significantly more distracted while using a cell phone, which we're going to call that P1. So we want to test is P1 greater than P2. So if you move that over to the other side, that'd be P1 minus P2 is greater than 0. And then go ahead, and anytime you write down these for an actual part, we need to define what they are. So P1 is proportion, you could say true population proportion of people who miss exit using cell phone. And then P2 is the proportion of people who miss exit when talking to passenger. Who miss exit when talking to passenger. Okay, so notice my verbiage. I did not say proportion of people who missed ED past tense the exit, right? We know that 7 out of 24 missed the exit. That's your PCAT. We just want to talk about in general the proportion who will miss the exit when using, or who missed the exit. Just don't use past tense when you're defining your parameters, because past tense sounds like the sample result, which is not what we're trying to decide about. Little details. Okay, so for part C, it says one test of significance that you might consider using the answer to answer the researcher's question is a two-sample z-test. State the conditions required for this test to be appropriate, then comment on whether each condition is met. So just notice how this is worded. They want you to state the conditions in general and then say, okay, are those conditions met for this problem specifically? Okay, so the way I would do these type of problems is first state our conditions that we need. Our first condition we meet is random. I should have put independent, right? Independent random samples. I'm just going to have to write it after random. And because it's two groups, you need them to be independent. Samples. Or what goes with that? Or it can be random assignment of treatment. That's the first condition. Our second condition has it, you don't always need it, which is important in this case. So in this case, the 10% condition, or the 10% rule, is only if random sample without replacement, which normally if you're doing a random sample, it's going to be without replacement because you don't want two of the same person in your sample. Your sample size needs to be less than or equal to a tenth of the whole population size, which you can word that, put that in words if you don't like that notation. You can say sample size is less than 10% of population, or however you want to word that, or you could write it out like that. And the last one is to check if it's normal, and if it's a proportion problem, we use large counts condition. Right, if we don't already know it's normal, you got to check large counts condition, which states in times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. But now think about this, that we don't know our true p, so we're using p hat, and we have two different groups, p1 and p2, so you also got to check it for 2 is greater than or equal to 10. So those are our three rules in general. Now we're going to see if they're met. So our first thing is, now how did it word it? Then comment on whether each condition is met. So we'll say for our test, to show now we're talking about our specific test, was it random sample or random assignment? We know, we already said there was randomly assigned treatment. So I'll say there was randomly assigned treatment So because of that, oh, I didn't realize how crooked it was. Because it was random treatment and not random sample, we don't need 10% rule. So we don't need 10% rule. And so that covers the first two. Now we can check large counts conditions. So it might help if you write it all down. So our first group that got the first treatment, wasn't it 24 in each group? Yes. N was 24 and P hat 1 was 7 out of 24. And I'll call that N1. And then for our second group, N2 was also 24 and our P hat 2 was 2 out of 24. So 24 times 7 out of 24. Oh, looky there. Is that greater than or equal to 10? Because this is just number of successes. That the 24s cross off, that's 7. Which is not greater than or equal to 10. So we already failed. So you don't even have to go check the other 3 we're supposed to check, right? 7 is not greater than or equal to 10. So does not meet LCC. So let me make sure that there wasn't anything else. State the conditions, which we did, and then comment on whether each condition is met. And so we did that. So we can just leave it at that. So then part D says, using an advanced statistical method for small samples, because our sample was too small, right? That's what this is checking. Large counts condition is checking that our successes and failures are big enough, which this was too small. So they used some other method, and the researchers reported this p-value, and they just want you to interpret what does that p-value mean and what conclusion would you make with that p-value. So first we're going to interpret the p-value. So p-value interpretation. How do we start this off? At assuming the null is true, which if you can put that in, whatever you can put in context, go ahead and try to put it in context. So what is our null from part B? It's that P1 equals P2. Or another way to word that is that the proportion who missed their exit when using a cell phone equals the proportion who missed their exit when talking to a passenger. So we're going to, or you could say that there's no difference. So however you want to word that. Assuming the proportion who missed their exit when on cell phone and when talking to a passenger are equal, right? So that's all just saying, assuming the null is true, the probability, our p-value is the probability of getting our sample result. So what is our sample result? Our sample, we didn't actually find it, but our sample difference, because if we were going to do this, we would have done the difference of p hat 1 minus p hat 2. So it's the probability of getting our sample difference in our proportions, or something, that looks like the same thing, or something more extreme, is, and then whatever that p-value is, 0.0683. So it's the probability of getting our sample result or something more extreme if that null is true. So because that is considered a large chance, because it's greater than 5, we do our interpretation, so our conclusion. So that then our conclusion, when we do a test based on that p-value, is since p-value is what? Greater than, and I probably should have put the p-value when I write it right here, 0.0683 is greater than alpha equaling 0.05, we fail to reject. I feel like I'm going crazy because I'm making so many little mistakes. Fail to reject HO, and that means we do not, right, have convincing evidence. We do not have convincing evidence for HA, which, what is HA? The proportion who missed the exit when using the cell phone is greater than the proportion who missed the exit when talking to a passenger. For the proportion who miss exit when on cell phone being greater than proportion who talk to passenger. Okay, so those are two different interpretations, both important, and you need to understand when to use each one. So hopefully that helps, and if you have any questions, please let me know.